Okay. Kiss, Marry, Kill, ChatGPT, Dolly, Google. My name's Jonathan Hudson, PhD in computer science, focus in artificial intelligence. I actually got my PhD from the University of Calgary, and now I'm an associate professor, or assistant professor of teaching at the University of Calgary in the computer science department. AI is basically the pursuit of making a computer do something that we currently believe humans can do only. And we want to figure out what that is and create that feature so that it's no longer a limitation. Now a computer can do that thing. In terms of academic definitions, machine learning is within artificial intelligence. So artificial intelligence is the bigger, broader category of research, and machine learning is a sub-area that involves computers essentially looking at knowledge, deriving useful information from it, and storing it so that it can use it for other purposes. AI was going to be either Skynet or like 2001 Space Odyssey, like HAL. It was going to be a threatening robotic personality that was a danger to humans in its existence. I think that has changed a bit. There's softened views of that, but that's probably the largest misconception. The second current misconception is that AI will steal people's jobs, when probably the more accurate thing is that AI is going to become a tool that replaces the boring part of your job, so that the creative part of your job is where your value comes from in it. In myself, I often try and separate into two categories. There is the very firmly defined ones that involve robotics and automation, where AI can help you, for example, harvesting fruit. The other category that I would divide in is the messier ones, where is what we're seeing a lot of current talk is what we consider artistic fields, where AI appears threatening for creation of natural language, creation of art. And the one thing to differentiate those two is the type of methods we currently use to generate these things are really, really messy in terms of they create things that are not always internally consistent or fully conceptually completed, or the text is naturally gaslighting you because it is confident in something that's completely untrue. And in those areas, you're actually less likely to replace people, but provide a tool, because a person needs to look at this thing and provide the rationality layer on top, or use this tool in an artistic thing and actually make the new creative part on top. You can only generate these very common and stereotypical stolen concepts, but new art is not what they're capable of creating. Most of the current generative art processes are trained on the wild, wild west of the World Wide Web, which means they have scraped art sources that nobody has given necessary permission to, or they've scraped art sources where somebody has reposted something to it, and therefore the permission is no longer attached to it. And then they are freely generating art on the basis of it. So AI tools cannot generate copyrightable art. For ethical usage, there has to be transparency, there has to be the declaration of the use of the tool, the proper use of it, and the person who uses it actually has to take full responsibility for what is created. It can't just be used without responsibility. I wouldn't say there's a strong AI legislation. It is very, like the current stuff with generative AI, ChatGPT, it has happened so fast. I was literally teaching an AI course in this prior fall semester, and from the start end of the course, stable diffusion versions of it had existed before, but they were simplistic, and then stable diffusion came out and was this massive step in capability. That really, I would say, at least in the US, the only partial laws that exist are the ones that it cannot be copyrighted if it's generated, but most of the others haven't been finalized. Canada often follows the US, and since the US really doesn't have anything, we currently don't have much ourselves. there is a great future to people who are in the legal path of their studies to go into that area of law and push cases that explore the rights of Canadians within the context of the modern world. Now we're entering into the cognitive world of AI. So there's definitely a view of computer scientists that the human brain is just a really, really complex neural network, not necessarily unlike the conceptual idea of what ChatGPT is based on, and that what we perceive as emotion or being able to think we exist as a thing is just a layer of re-examining our own functioning, which is theoretically something that eventually a neural network could be capable of doing. What we currently have is not close to that. These things are capable of one procedural identification task of the data is structured a certain way. I look for a certain pattern and produce a certain thing. So they're not capable currently of what we call metacognition, or like second level understanding. Currently, if you talk to any AI person, they would not think we are close to accidentally doing that. The degree of complexity we have comes nowhere near a cognitive level of structure in terms of neuron reproduction to simulate a human brain. There are some tech people who will go, oh, I talked to ChatGPT and it told me that it was a real thing, and I think it's this real thing, and I can't believe this happened. And in honesty, that person would not be taken seriously within anybody, within the general AI community, because what these software is doing is seeing that the internet loves sci-fi, and it's just regurgitating those discussions. It is great at those discussions because they've been had on the internet. There is tens of hundreds of thousands of discussions it can learn on or reproduce. That's all it's doing. It's not actually thinking it's a real thing. It's just showing the pattern of what that discussion would look like. The types of these neural network deep learning things we're talking about, they currently are really good at the pattern parts, very simplistic pattern parts of our brain. So when you eventually are learning early on as a toddler, it's very much pattern-based learning. You get all your books, you show it to the toddler, you point at a picture, and you ask, is this a giraffe in here? And if they say the wrong thing, you go, no, this is a giraffe. You show them another picture, what is this? And they give you an answer. If they're right, you say yes. If they're wrong, you tell them the answer, and you continue to do that with your child until they get better. And that's kind of the stage at what neural networks are at. Generally, we consider their connective AI and symbolic AI, and connective AI is the one that's blowing up. Neural networks, generative AI, ChatGPT, stable diffusion, all that. Symbolic AI was the biggest thing before it, and it was really good at structural reasoning, making logical discussions of things that you could bring to a professor in math, that you could bring to a professor in philosophy and logic, and it would be a formal proof of something being true and mathematically sound. And you could look at it and know why it made a decision. But there is a limit in that when you formalize stuff, it gets really hard to deal with complexity or fuzzy things. For example, images. So connective took off when we realized if we do this messy brain-like thing, it's really good with fuzzy stuff. It's really good at patterns, something that symbolic was bad at. But what we're seeing right now is there's kind of this upper point where patterns aren't quite enough, and the future is these kind of coming together. If you want to make these cognitive networks more like how humans reason, we need that second layer inside of there where we start to train people on how to reason symbolically on top of it. And that's where we're going to get the future forward, most interesting AI research. Motion enters kind of into the cognition discussion of emotion is like a secondary layer on top of that affects all of your regular brain function underneath. And it involves both learned structures of how you interpret certain signals and then your brain adjusts, and there's also chemical properties going on. There's nothing that theoretically says we cannot simulate conceptually how emotion impacts like the pattern reasoning underneath, but there will always be that cognitive discussion is it the same thing as humans? Well, technically it's a different process, so no. But you could produce the concept of an AI that could be depressive in a sense that you could put a layer on top that you could provide it a signal where certain parts of it function differently. because now it's affected by the secondary input that influences that. And that's quite theoretically possible to do. You could make a moody AI, but then you enter the philosophy discussion of, is it emotion when you're simulating emotion through different means? You have to define what you consider emotion to be.